Have you ever wondered what mysteries lie beneath the surface of our world's oceans? It's a question that has captivated the human imagination for countless generations. From the earliest civilizations, the sea has been a source of fascination and fear, a realm of unknown dangers and untold treasures. Ancient seafarers gazed upon the vast expanse of water with a mixture of awe and trepidation, their tales filled with monstrous creatures and fantastical islands. The ocean was not just a physical entity, it was a powerful symbol, a metaphor for the great unknown. As societies grew and technology advanced, our relationship with the sea evolved. No longer were we mere spectators to its majesty. We became explorers, embarking on daring voyages to chart the uncharted, to conquer the unconquerable. The ocean, once a symbol of the unknown, became a challenge, a puzzle to be solved. This is where deep sea exploration comes into play. It's not just about sailing on the surface, it's about delving into the very depths of the ocean, where light fades and pressure mounts, where few life forms can survive. It's about investigating the physical conditions of the ocean floor, the chemical composition of the water, the bewildering array of creatures that call this alien world home. It's about pushing the boundaries of human knowledge and capability, about exploring the final frontier on our very own planet. Deep sea exploration is an endeavor that combines the thirst for adventure with the rigor of scientific investigation. It's a journey into the heart of the unknown, powered by curiosity and courage, driven by the desire to understand our world and our place in it. It's a testament to our enduring fascination with the sea, a fascination that has shaped our history, our culture, our very identity as a species. The desire to uncover the secrets of the deep sea has shaped much of our history and continues to drive scientific discovery today. So let's dive in, shall we? Let's explore the unseen depths of our world's oceans, and in doing so, let's learn more about ourselves. The journey into the depths began in earnest during the 19th century. When we consider the vast expanse of our oceans, it's almost impossible to imagine the audacity of those first explorers who dared to venture into the unknown, to plunge into the inky depths of the deep sea. Yet it was in the 1870s that the first significant leap into this uncharted territory was made with the HMS Challenger expedition. This was an endeavor like no other. For over 3 years, the Challenger traversed the globe, its crew conducting a series of deep-sea soundings, dredgings, and temperature readings, contributing to over 50 volumes of scientific findings. They discovered around 4,700 new species, mapped the ocean floor, and even plunged a sounding line to a depth of over 5 miles in the Atlantic. This was the first comprehensive study of the world's oceans, and it laid the groundwork for the science of oceanography. Yet the Challenger expedition was just the beginning. As the 20th century dawned, technological advancements allowed for the development of submarine technology, offering a whole new perspective on the deep ocean. The first manned descents into the deep began with intrepid explorers like William Beebe and Otis Barton, who, in the 1930s, descended to a depth of over half a mile in a spherical submersible named the bathysphere. These early explorations were fraught with danger and uncertainty. The crushing pressures, the pitch-black darkness, and the unknown creatures lurking in the depths were all formidable challenges. Yet these brave pioneers, armed with a thirst for knowledge and a sense of adventure, dared to venture where no one had gone before. Their courage and determination laid the foundation for our understanding of the deep sea today. These brave pioneers opened up a new world, but we were just scratching the surface. Technology has advanced leaps and bounds since those early expeditions. We've come a long way from the crude diving bells and rudimentary submarines of the past. Today, we explore the ocean's depths using cutting-edge technology that's as fascinating as the mysterious world it uncovers. Among the game changers in deep-sea exploration are remotely operated vehicles, or ROVs. These unmanned submarines, controlled by operators aboard surface ships, can descend thousands of feet below the surface. Equipped with high-resolution cameras and robotic arms, ROVs allow us to investigate underwater landscapes, gather samples, and even interact with sea life, all without leaving the safety of the ship. But what if we could explore without the constraints of a tether? Enter autonomous underwater vehicles, or AUVs. These self-guided machines can venture into places too dangerous or inaccessible for humans or ROVs. From mapping the seafloor to studying marine life, AUVs are expanding our understanding of the ocean's depths. Satellite technology, too, plays a crucial role in deep-sea exploration. By bouncing signals off the ocean's surface, satellites can create detailed maps of the ocean floor. This technology has revolutionized our ability to locate underwater mountains, deep-sea trenches, and other geological features hidden beneath the waves. Then we have deep-sea submersibles, the real stars of this show. These high-tech submarines can withstand the crushing pressures of the deep ocean, allowing humans to personally witness the wonders of the deep. From the comfort of a submersible, explorers can observe strange creatures, unearth ancient shipwrecks, and even collect samples from the ocean floor. The advancements in technology have truly transformed how we explore the ocean. No longer are we limited by our own physical capabilities. Instead, we're empowered by machines that can withstand the harsh conditions of the deep sea, allowing us to explore further, deeper, and with greater precision. With these tools, we've been able to delve deeper and uncover more of the ocean's secrets than ever before. Our journey into the deep has not only been a story of discovery, but also of danger. As we delve deeper into the abyss, the challenges mount. High pressure that can crush submarines like soda cans, freezing temperatures that can freeze machinery in an instant, and the ever-present risk of equipment failure are just a few of the threats that explorers face. Yet it is not the dangers that define deep-sea exploration. It is the triumphs over these adversities that make the journey worthwhile. Against all odds, we have discovered the most astounding phenomena in the deep, phenomena that have reshaped our understanding of life itself. Take, for instance, hydrothermal vents. These underwater chimneys spew out mineral-rich water heated to boiling point by the Earth's magma. Initially, scientists believed that these extreme environments would be devoid of life, but they were in for a surprise. Thriving around these vents are dense communities of unique organisms, living in pitch darkness, withstanding crushing pressures and boiling temperatures. These creatures survive not on sunlight, but on the chemicals spewed by the vents, a process known as chemosynthesis. Creatures like the giant tube worm, which can grow up to 8 feet tall, or the yeti crab, which farms bacteria on its furry claws for food, are just a few examples of the marvels that inhabit these vents. These discoveries have changed our perception of where and how life can exist, not just on Earth, but potentially on other planets as well. But these discoveries come at a cost. Each dive is a gamble, with the risk of equipment failure looming over every expedition. One wrong move, one unexpected pressure spike, and the journey could end in catastrophe. Yet, despite these dangers, the allure of discovery propels us forward. For every peril, there is a promise of a new discovery, a new understanding, a new perspective. The deep sea may be fraught with danger, but it is also teeming with potential. Despite the risks, the allure of discovery pushes us to venture further into the unknown. As we look to the future, the possibilities for deep-sea exploration seem limitless. In this ever-evolving landscape of exploration, we're seeing a surge of innovative projects and ambitious plans. Technological advancements are revolutionizing the field, and the horizon of discovery is expanding like never before. We're entering a new era of exploration, one where we're not just spectators, but active participants in uncovering the mysteries of the deep. The potential for new technology, such as artificial intelligence and machine learning, is immense. These tools are transforming the way we explore the ocean's depths, enhancing our abilities to gather data, analyze it, and make insightful conclusions. Imagine autonomous submarines, navigating through the intricate landscapes of the ocean floor, capturing high-resolution imagery, and collecting valuable data. These intelligent machines can venture where humans cannot, breaking barriers and pushing the boundaries of our knowledge. But it's not just about the technology, it's about what we stand to discover. The deep sea is a treasure trove of secrets waiting to be unveiled. There's potential for discovering new species that could redefine our understanding of life on Earth. There's also the promise of resources, precious minerals, and compounds that could be pivotal in various industries, from pharmaceuticals to energy production. There's a profound sense of urgency, too. As climate change impacts our oceans, understanding the deep sea becomes more crucial. It's not just about what we can find, but about what we can learn and how that knowledge can help us protect these vital ecosystems. The future of deep-sea exploration is teeming with potential. It's a journey of discovery, of pushing the boundaries of what we know and venturing into the unknown. It's about solving the puzzles that the ocean presents us and learning to appreciate and protect its vast and complex beauty. The mysteries of the deep sea continue to captivate us, driving us to explore, discover, and understand the last uncharted territories on our planet.